Hello, space enthusiasts! Today I will leave you with a comparative study of Venus and Earth. Yes, these two planets are as different as heaven and hell. Earth is a natural paradise where life goes on under blue skies, but what about Venus? Venus is a hell, scorched by a crushing atmospheric pressure and clouds of sulfuric acid. However, we can't stop thinking of these two planets as sisters, because they both have about the same mass and radius and are rocky planets, sitting side by side in the inner solar system. So why are they so different? What do these differences tell us about our search for life? The international astronomical community recognizes that understanding the habitability of planets is a critical part of space science and astrobiology. When we search for signs of extraterrestrial life, we don't really know what we are actually seeing when we study a distant exoplanet. If we find an exoplanet that shows signs of life, we won't be able to visit it, study it closely, and sample its atmosphere. So we turn our scientific focus to the rocky planets in our own solar system. A complete model of rocky planets would be incomplete without including planets like sister planet Venus, not only because they look habitable, but also because they are like hellholes. A new research perspective, published in the journal Nature Astronomy, examines how the two planets differ, and what that differentiation might cause. It is titled, Venus, as a Stabilizer for Planetary Habitability. Lead author is Stephen Kane of the Department of Earth and Planetary Sciences at the University of California, Riverside. Co-author is Paul Byrne of the Department of Earth, Environmental and Planetary Sciences at the University of Washington. One of the main focuses of the planetary science and astrobiology community is to understand the wide range of factors that control the evolution and sustainability of temperate surface environments such as our Earth, Kane and Byrne write. The atmospheres of several important rocky planets in the solar system provide a critical resource for studying these habitability factors, and these models can be constructed for application to exoplanets. From their perspective, the solar system's twins offer the best opportunity to study how similar planets can have such different atmospheres. The better we understand these differences, the better we can understand how rock worlds evolve over time and how different conditions affect habitability. Earth is an exception. With its mild climate and surface water, it has been habitable for billions of years, even experiencing periods of climate that severely restricted life. But when we look at Mars, it was habitable for a while and then lost its atmosphere and surface water. Mars's situation must be more widespread than Earth's. But Venus is a challenge. We cannot see its dense clouds except by radar, and no one has tried to land a spacecraft there since the USSR in the 1980s. Most of these attempts failed, and those that survived did not last long. We cannot understand the history of Venus without better data. The simple answer is that it is closer to the Sun, but this answer is useless. Venus's evolutionary journey to its current runaway greenhouse state is a matter of debate, traditionally attributed to its closer proximity to the Sun, Kane and Byrne explain. But when scientists take a closer look at Venus and Earth, they find many fundamental differences beyond their distance from the Sun, like different rotational speeds, different inclinations, and different magnetic fields. This means we can't fully measure the effect of more sunlight on the planet. Here's the author's main point. The differences between Earth and Venus make Venus a powerful part of understanding the habitability of rocky exoplanets. Venus is a critical juncture for the planetary habitability discourse because its evolutionary story represents a different journey from the Earth-centered narrative. Although it is likely that the origins of both worlds are similar, the authors write. The authors note that surface water, a basic requirement for life, is a fundamental requirement. But the question is, what are the factors that determine how long surface water can persist? By this measure, planetary habitability research could focus on the conditions that allow the sustainability of surface liquid water over geological time, they write. Earth and Venus are at opposite ends of the spectrum of habitability of rocky planets. This is an important lesson we can learn from our own solar system. Therefore, understanding the pathway to the Venus scenario is as important as understanding the habitability pathway that characterizes Earth, they write. The researcher duo created a list of some of the factors that determine habitability on Earth and Venus.